Hello students, welcome again. We are going to learn more programming concepts of Arduino in this video. So for a brief revision, we said that Sketch is a collection of instructions for your Arduino, and these instructions are also called programming statements. One of the sample statement that I have listed down is something like this: serial.println hello. Okay, what is this statement doing? Is it dependent on some other statements? All these questions may be popping up in your mind. We are going to answer all of them in this video as well as the future videos. So before we go and start writing the program, we are going to learn small concepts, implement them on Tinkercad or IDE, test them, and then go ahead. So one by one we will learn those concepts, implement, test, and move ahead. So here the first thing that we have is method. Method is basically a group of statements that perform a specific task. They perform a set of subtasks. So imagine you have a robot which is having 3-4 different functions like tracking human being or tracking walls or fire, and then controlling the motion of the motors or running the fan or fire extinguisher. All these things are subtasks. Set of statements related to one subtask is called method. So your Arduino sketch is made of different methods, and these methods combined together go into one sketch, and that is uploaded on your Arduino. A method can be with parameters or without parameters. So what is that? Parameters are the arguments that we provide for those set of statements. Okay, imagine that you are going to calculate the area of a rectangle. You need that what is the length and width of my rectangle, then only you can calculate that, right? So example is this: I have a function which is CALC, area of RECT, calculate area of a rectangle. It is going to return an integer, and I need two input parameters. One is length, one is width. Both are integer. These can be real numbers also. Then my programming statement says define a new integer called area, and area is length multiplied by width, and return area. That's it. So set of these statements is what we call a method, and in this method I am taking some input parameters. There can be methods without parameters. Okay, so what can be that? These are the parameters where there will not be any input parameter. So the parenthesis will be empty. It is going to return void. Example where you have no such things are you just want to play a sound. Okay, fine. You don't need any input parameter for that. You simply are directing your Arduino or a robot being controlled by Arduino that okay, play this sound for 5 seconds. A sample code is here: void play sound, no parameters, tone 5, note A5 A4 50, delay for 600, next tone, next delay, next tone, next delay. What are all these things? What is tone function? What are the three parameters of tone function? We will discuss them in one of the videos on tone generation. But right now our focus is that the main method, which is play sound, is not having any input parameters. So that is how we can have two different types of methods in our Arduino sketch. Let us write a sketch now. Normally, whenever you start a programming language, the first one is Hello World program. We are going to write a similar one. We are going to direct our Arduino that write a program which can print Hello World after every 1 second of delay on serial monitor. Fine. So we say First of all, I need to have two functions. First one is setup serial.begin 9600. What is this? This statement is going to start serial communication at 9600 baud per second. The detailed discussion on serial communication will be in a video on serial communication, but roughly understanding, this command is starting our serial communication with the computer at this rate. In the loop function we say serial.print hello world, delay of 1 second. 1 second means 1000 millisecond. That will keep on repeating. So this is our simple program. We are printing hello world on serial monitor after every 1 second. Now we are going to test this on our Arduino IDE. Before I go and open IDE, I need to go to Control Manager and search for Device Manager. In this control panel Device Manager, we are going to see all the physical devices, and we will go to ports and see where is our Arduino connected. This serial port number, it can be 4, 5, 7, 3 depending on your machine's history with serial port devices. So I note down this COM4. Okay, now we are going to go to IDE. So here I came to IDE and I have written the program here. This is the same program that we discussed in the PPT. Now, first thing, go to Tools and select the board. This board is Uno. Fine. Second thing, go to ports and check the correct port. If you don't select the correct port, uploading will not happen. So once you write the program, the first thing is to verify. On this tick mark, you will click, and when you do that, the compilation will start, and if there are no errors, it will show done compiling. By mistake, if you have any error, you can press Ctrl S to save it, and you can also choose the location where you want to save it. All these facilities are there as a standard application software. If I run the verification now, it shows that error expecting a semicolon before delay, right, in the void loop function. So before delay we are expecting a semicolon. It's very interactive. Save it and verify again. Now it is compiling and say yes, it's done with compiling. Then you say upload. If your COM port is correctly defined, it will say done uploading, all fine. Now uploading is done, program is running on your Arduino. Where is the printing? For that you need to go to Tools and Serial Monitor. You can access it with Ctrl Shift M also, and you can see hello world is being printed. You are not able to see new hello worlds coming, so say clear output, and now you can see again the new outputs are being printed. It is being printed at 9600 baud per second. Okay, fine. So now we are going to test the same thing on Tinkercad. So we are at Tinkercad now, and we are going to go to the library and drag one Arduino board. So we drag and drop it here. When we do that, a code is also available with us. We have three options to code it. One, using only the block programming. The second is using block plus text. If you click it, you are going to see an equivalent test code which is there generated from these blocks. And the third one is only text based. So let us see the block based programming first. So I am going to delete some of these lines. These lines are basically for LED blinking. So let me drag it and I remove it. So you can see whenever I am deleting some of the lines, the corresponding lines are getting deleted from here also. So I delete it. Now here we have the option print to serial monitor. I take this and as soon as I take it, serial.begin is also added and serial print hello world is also added, and I attach it with the delay, so these got attached now. All I have to do is run this program. You can always click on this code to hide your code. Okay, it will be hidden, and you can click back so that the code is visible again. Now you can start the simulation, and when you start the simulation, you can see the code is running. It is printing hello world, but where? It is printing on this right bottom serial monitor. So you can see hello worlds are being printed. You cannot see them coming up, so you can simply say clear it, and now with every second one new hello world is coming, right? So this is block plus text. This may not be supported every time. The problem can be all the libraries cannot be converted from block to text, and vice versa. All the libraries are not supported in blocks. Most of the libraries are supported in text. So it's better that we switch to text as soon as possible, because for the advanced level or intermediate level, text will be better suited. Block level is mainly targeted for the beginners level. To do that, we say go to only text mode, and it is giving us the warning that there is no way back. Okay, so we say fine, we are going there, and now it is only the text. Now if I make any change here, there will not be any block which will be created. Just to make a difference, I am putting an exclamation here so that we can see that the output is different. Let me clear it from here, and we start the simulation again. So once we start this simulation, now you can see the new hello worlds are coming. These are different from the first one. These hello worlds, if you want to differentiate, you can click on clear, and you can see that we are getting the new output here, right? So students, we learned about our first program on Arduino and how to bring it on the Arduino board using IDE or Tinkercad platform. We'll continue our learnings on variables and strings in the next video. Thank you.